Hey everyone, before we get to our first test, I have a couple little odds and ends that I want to talk about. The first one is about measurements of center. So, when we talk about the mean, and we said that the mean is going to get thrown off by skewed values and outliers, I want to talk more about that skewness. So, this is a distribution that is similar to what we talked about for how the mean and median get affected by outliers. So we have this outlier of 99, and we said the mean is going to be thrown off by this 99, but let's talk more specifically about how. So the median, first of all, here would be 4. That'd be the middle number of the data. But the mean, I want you to pause and think, is the mean going to be bigger than 4, or is it going to be smaller than 4, and why? Without doing the calculation. And in this case, you should know that the mean should be greater than the median. Because when we add these values up, 99 is a pretty big number from this list to be adding. And so that's going to push that mean to the right. And let's look in general at a skewed right distribution. So a skewed right distribution would look something like this. And what's going to happen is that the median will be in the middle. It'll be somewhere around here. This would be where the median would be. And what's going to happen is that the mean is going to get pushed off by these higher values. These higher values are going to get added to it, and it's going to push the mean off to the right. This is where the mean would go. So the mean's getting pushed to the right in a skewed right distribution. Now, if we have a skewed left distribution, so let's draw the tail over here on the left. That's what's causing the skewness. And then we have this bunch of data here. Then the opposite's going to happen. The median's still going to be around here. That's going to be around where the middle value is. And the mean is going to get pushed down by all these small values that I'm adding over here. And that'll put the mean around here. So what happens is that the mean is pushed in the direction of the skewness. So that means that if our distribution is skewed to the right, then our mean is going to be above the median because those high values are going to push the mean to the right. If we're skewed left, then these lower values that are causing the skewness is also going to push the mean down. So the mean is going to be less than the median here. So the way to remember that is that the mean gets pushed in a direction of skewness. And that's also why if we have a symmetric distribution, then the median and the median are going to be about the same. Because there's not skewness throwing off the balance. And in that case, we want to use the mean for center and standard deviation for spread. For skewness, we want to use the median and interquartile range. Speaking of standard deviation, I want to talk a little bit more in depth about it. And I want to give you an idea of what the formula looks like and how it gets calculated. You won't have to actually calculate it very much, but I just want to show you an example so that you get a better understanding of how the formula works. So let's talk about what each of these stand for. Remember, this is sum. So we're adding up a whole bunch of values. So each time a number appears in the list, we're going to do it. So x sub I is the value that we're talking about. X bar, you should know, is the mean. And n, you should know, is your sample size. So in the example we're about to look at, n is going to be 5. So what this is going to look like is that we're going to be adding 5 different terms up, one for each list. I'm doing 1, 2, 3, 4, 5 so that it's nice and easy. First, we need to calculate the mean. The mean in this case would be 1 plus 2 plus 3 plus 4 plus 5, all divided by how many numbers there are, which is 5. This would be 15 over 5, or 3. So the mean is 3. So what we're going to build here is have a bunch of terms added together. N is going to stay 5, because they're always a list of 5 numbers. And then we're going to put these values in. The first value that we're going to look at is 1. And then we're going to, hold on, this is squared. Then we're going to subtract the mean. And the mean in this case is 3 squared over 5 minus 1. Plus, and then we're going to do the same thing for 2. Over 5 minus 1. So we're going to take the value that we're looking at, which is the next number in the list, that's 2, minus the mean, which is 3, all squared, over 5 minus 1, plus, we're going to do the same thing for 3. And you can start to see how this is tracking. I said an interpretation of standard deviation is average distance from the mean. For example, this part that I'm putting in right now is going to be 0. Because if you look at this term, 3 is at the mean. So its distance from the mean is 0. So it is a way of measuring that distance from the mean. And I'll fast forward the rest of this formula real quick. Okay, so we take these, add them all together. So for our first term, we have 1 minus 3, which is a negative 2, which is squared. So that's going to be 4. Over 5 minus 1 is 4. Plus 2 minus 3 is going to be negative 1 squared. It's going to be a positive 1. Over 5 minus 1 is 4. Plus 3 minus 3 is 0 squared is 0 over 4. Plus 4 minus 3 is 1 squared is 1 over 4. Plus 5 minus 3 is 2 squared is 4 over 4. And hopefully doing this is helping you see some things about the formula. First of all, that the closer you are to the mean, the smaller the component of that formula is in that number. You should see that standard deviation is always going to be positive, because once I square this, then my distance is always going to stay positive. Then you should also know that the further away something is from the mean, then the larger the component is in the formula. So this is why it's a measure of spread, because more spread out values, more numbers that are farther away from the mean, is going to mean a higher standard deviation. So that's why it's a measure of spread. So we have 0 here, we have 1 here, we have that another 1 here makes 2, a fourth and a fourth is a half, so we actually have 2.5. 2.5 would be our standard deviation. And hopefully you're also seeing why we don't spend a lot of time actually computing this, because it's a bit of a long process and the calculator can just do this for us. But hopefully this gives you a better understanding of the inner workings of the formula and why it's a measure of spread and how it works. So that should be all you need for the Chapter 1 test. Thanks for watching, and I'll talk to you more soon.